Hello, and welcome to this fun and important module from Analytics. My name is Jordan, and I will be with you as we walk through and discuss these important concepts. The topics we will be covering are ones that are common in the analytical world, but sometimes cause confusion and bad analysis: correlation and causation. These two subjects may be familiar or something you have heard before, and we want to help you walk away with the skills necessary to analyze between correlation and causation correctly. As a result of this learning module, you will walk away with the following understanding: what is correlation and what is causation? Why these topics are so important in analytics, and why it is so important to differentiate between correlation and causation. You will also learn how these concepts can be misunderstood and can cause bad analysis. We hope you will dig in and take notes to understand how these concepts apply in your individual roles and industries. And as always, please dig into the other modules of the Click Continuous Classroom to enhance your data and analytical literacy. To begin to understand and learn more about correlation and causation, stories and examples will help illuminate these concepts. Note, both of these examples are hypothetical, but can come close to real-world examples and thoughts. The first example we will walk through is a visualization that shows sales and commissions paid out. The chart we are analyzing is a visualization of a company's sales totals over a given time period, compared with the company's commissions paid to sales representatives over the same period of time. Notice in our visualization there are two y-axes, one that represents sales and one that represents commissions. As we analyze the visualization, we notice that the two trend lines are following a similar path. In fact, it appears they almost mirror each other. Noticing this similar path, maybe the lines are correlated together. Correlation simply means that a mutual relationship or connection between two or more things exists. In other words, as you see one variable increase or decrease, a second variable will also increase or decrease in parallel to some degree. But does this mean that one thing is causing the other? This is the term causation. With two lines or metrics correlated, does that mean causation is happening? Two metrics being correlated does not necessarily mean causation, and that is what we want to explore in this module. The second example visualization we want to analyze is one that shows pie consumption and jellyfish stings in the United States. Here we are analyzing the amount of pie consumed per person in America against the amount of reported jellyfish stings over the same time period. Looking at this visualization, we are seeing a similar correlation as the previous chart. As one of the metrics increases or decreases, it seems the other metric is following suit. But with that in mind, are we really saying that as pie consumption per person has increased in the United States, this has caused an increase in jellyfish stings? Well, of course that sounds silly because it likely is. Herein lies a major problem within the concepts of correlation and causation, making the assumption that correlation equals causation. In analytics and data, a lot of metrics and variables will appear to mirror each other and will be correlated, but in no way does that mean one causes the other. To continue our learning on these topics, we now want to explore the concepts of correlation and causation separately, and then we will regroup and show these together again. The first topic we will cover is correlation. Correlation in statistics is a very powerful tool. Remember, correlation means as one variable tends to increase or decrease, a second variable tends to increase or decrease in parallel to some degree. In statistics, correlation is represented by a single number, and that number shows the relationship between the two variables. Correlation is measured by the correlation coefficient and is represented by the letter R. We will not cover all the math that is necessary to calculate an R value, the correlation coefficient, as we want to discuss the concepts versus the technical math. The R value will fall between 1.0 and minus 1.0. When R equals 1, it is said that there is a perfectly positive correlation between two variables. When R equals negative 1, there is a perfectly negative correlation between two variables. The closer the R metric is to 1 and negative 1, the stronger the relationship between the two variables, whether positive or negative. Let's analyze the correlation coefficient. When the correlation coefficient R has a perfectly positive coefficient, r will equal 1.0. In general, the following can be a rule of thumb. If r is greater than 0, there will be a positive relationship. So what does a positive relationship mean? This means that if one variable increases, the second variable will also increase, or if one variable decreases, the other will decrease. The two are positively correlated together. When the correlation coefficient has a perfectly negative coefficient, r will equal negative 1.0. In general, the rule of thumb can be, if r is less than 0, there is a negative relationship. So what does a negative relationship mean? This means that if one variable increases, the other variable will decrease, and if a variable decreases, the other variable will increase. Sometimes a negative correlation will be termed an inverse correlation. As one variable goes one direction, the other variable will go in the opposite direction. Finally, what happens if r equals 0? Is this a positive or negative relationship? The concept of r equaling 0 is pretty straightforward. An r value of 0 means that there is no relationship between the variables, whether positive or negative. We gave a couple rules of thumb before. R greater than 0 is a positive relationship, and r less than 0 is a negative relationship. Let's modify these rules a bit more with this new information that r equals 0 means there is no relationship. The closer the correlation coefficient r is to 0, the weaker the relationship between the two variables will be. And the closer r gets to 1.0 and negative 1.0, the stronger the relationship between the variables will be. These are key rules to remember when it comes to correlation and the correlation coefficient. Let's transition in the module to see visualizations showing us the different relationships of correlation. First, let's see a visualization of a stronger positive relationship between two variables. The visualizations we looked at earlier in the presentation were both positively correlated. The sales commission visualization looked like the following. As you can see, as sales go up and down, the commissions follow in a corresponding manner. In our case, our hypothetical R value is 0.92. This would represent a strong positive correlation, and the variables are strongly related. Commonly, to view correlation, we look at scatterplot visualizations. Let's see our previous visualization of sales and commissions in a scatterplot. As can be seen in this scatterplot, as sales go up, we also see that commissions go up, giving us a positive correlation of R equals 0.92. What would a negative correlation look like? Let's see this in a visualization. Here we have an example of running a marathon. The more miles a person runs in a week, the less time it takes to finish a marathon. With negative correlation, when one variable increases or decreases, there will be an inverse relationship with the other variable. As in our example visualization, as an individual increases the amount of miles they train and run per week, the faster their marathon time will be. Our final example or rule of thumb is that when R equals 0, there is no relationship between the two variables. Here is a scatterplot visualization of this. As our visualization shows, no distinguishable pattern can be seen in the data. As variable 1 goes up, does variable 2 go up in a like pattern? The answer is no. There are points where variable 1 is low and variable 2 is high, and vice versa. Again, R equals 0 means there is no relationship between the two variables. Before we continue on to discuss causation, we want to discuss one type of correlation that you can run into: spurious correlation. Spurious correlation is a type of correlation where it appears a relationship exists between two variables, but in reality no relationship exists. Spurious itself means false or illegitimate. Think of the example of pie consumption and jellyfish stings. There is a correlation in the numbers, but it is a spurious correlation. No relationship exists in the amount of pie eaten and the number of jellyfish stings. This concludes part 1 of a 2-part video. Please close this browser window, return to the interactive